Hello, I'm Michael Wybrow, and in this video I'm going to talk to you about control flow, structures, classes, and enumerations in Swift. So the conditional structures are very similar to what you would have seen in other languages like C. The only difference is that there's no brackets required around conditions, and you can put them there because you can always add brackets to control the order of operations, but you don't have to, and it would be suggested that you don't. Loops are similar in Swift. Again, no brackets around conditionals. One notable change or difference to C is you don't have these traditional initialization conditional afterthought for loops like for I equals 0, I less than array length, I plus plus. The loop types in Swift, you have while loops with some condition, you have do while loops, which are called repeat while, and you'll notice a lot of Swift is about making or aims to be quite readable, so that makes the code self-documenting. You can have something that iterates through a number range with something like for index in, and you give a number range, in this case values from 1 to 4, as in 1 is less than 5, and here the number range from 1 to 5. We have functions in Swift. They look fairly standard. You have to specify the type of each of the parameters. If you want a return value, this one has no return value, so it doesn't require and can't have any return statement. This one has a return value that's an int, and the compiler will enforce that we have return statements from this function. Notably, when you call functions, you need to specify the name of each of these parameters. If you don't wish to do that, especially if you've named the function so that it has the name of that parameter in the function name, then you can put an underscore here and it makes the parameter anonymous. We still have the name here, which is how the argument is referred to in the code of the function. We can also return multiple values from a function using a tuple, and here basically what you're returning is a structure, and in this case the structure has a couple of named properties. The syntax for actually returning the value is you just do bracket and then the number of values separated by commas. Then when you get the return value, you can put it into a variable, and this will just be an object, and you can refer to the individual properties by name. Or if you want to, you can assign that object directly to multiple variables, including if you don't want one of them, you can just put an underscore, similar to how we did the anonymous parameter on the previous slide. And then you can just refer to these here. So for classes in Swift, we don't have this header source separation that we have in C and C++. All of the code of our classes is just typically in a Swift file. You don't have to do includes. These files are automatically included in the rest of the project, can be accessed from anywhere. Calling a class method or calling a method of a class instance looks very similar to what you would expect. You'll notice there's no semicolons on the end of any line in Swift. It's not required and you shouldn't put it there. And you can also make class methods if you want to by specifying that the keyword class before one of these. And in that case, instead of giving an instance, a variable that contains a class instance, you just give the class name as part of the call to that class method. We should talk for a moment about classes versus structures. Classes and structures are very similar in Swift. They can both have properties, both have methods, they both have initializers, that is constructors, which you would probably know. Both can conform to protocols, and what this means is they just have to have particular properties or methods implemented, and we'll cover this more later because we make use of it. But importantly, classes are a reference type, whereas structures are a value type. What this means is that anytime if you've got a structure stored in a variable and you assign it to a new variable, that second variable is a copy of the original structure. It's not the same structure. If you change the second one, the first one doesn't change. And again, as part of the workshop, we'll do some demos where we see the difference between these. Classes are a reference type. If you've got a class instance and you assign it to that's in a variable and you assign it to another variable, and you change one, they'll both change. That's what a reference type means compared to a value type. So there are some other differences. Structures have default initializers synthesized for them, so you don't have to write basic initializers if a structure is just something that holds a couple of values in its properties. And then things like inheritance and typecasting to find out the particular type of a class instance, they only work for classes. So the sort of general principle, and we'll try and make use of this in all of our demos, is that in writing Swift, we prefer the use of structures and enumerations whenever we're doing custom data types, but we use classes where they're necessary. And they are necessary in lots of places. So there are plenty of instances where we use inheritance and classes as part of writing and using things like UI view controllers, which we'll cover next week. So here's a quick example of a structure and an enumeration. For an enumeration, you can just say enum, give it a name, and give it a couple of values. And again, like this is all strongly typed. So then if we create a furniture struct, which is just a structure that has three properties, in this case name, that's a string, age, that's an int, and style, which is this enum type, then if we want to create an instance of this structure, we just say furniture and call the initializer, and it has one created for it based on just the three properties it has, and we have to specify chair, age, and here when we want to specify the name of the style, we can actually say furniture style.modern, but because it knows the type is furniture style here, we can just say .modern. And Swift has a really good compiler that will do syntax completion as part of writing code, so it will give you the option of choosing modern or antique here. So here's an example of some classes and inheritance. Here's a furniture class. Here for the class, we've written its initializer ourselves, which we need to, and we can do things like assign an initial value to the age property. Here's an example of us creating an instance of this chair or furniture class, and then modifying a particular property of which we just do via the class instance. Here's an example of creating a subclass. Old table, which inherits the properties from furniture, but also has a price property as well. So here's the initializer. We have to initialize things that are only part of the subclass before we call the superclass's initializer. And we can do that here. So we initialize, we need to call the superclass's implementation. We do that via this super keyword and just call the initializer. And then once we've called it, we can then access the properties in here. So if you need to use the age property and you want to initialize it, you have to do it after the call to super. And then in here, we can create an instance of this and refer to the properties name and age. And the type of table here could either be old table or it could be furniture. Here's an example of what a method actually looks like within a class or within a structure for, or within a structure. In this case, here's one that returns a string. And here's us overriding that method in a subclass. You have to give the keyword here to show that you're deliberately planning to override this method. And if you need to, you can call the superclass's implementation from within here, again via the super keyword, similar to our initializer. All right, the final thing I'll talk about in this video is memory management. So in C and C++, you as the programmer are responsible for allocating and freeing memory. And what that means is that forgetting to release memory when you no longer need it results in memory leaks. It also means that if you free things early and then reference it, you end up with things like seg faults. In other languages, we have uh, garbage collection in languages like Java and C Sharp. And what happens there is that um, the virtual machine scans the heap and the stack, and it looks for references to things, and it is quite clever about freeing them, but it goes through this process periodically. And the downside of that is, while we don't need to worry about freeing memory, the garbage collection process can be slow. So iOS uses a technique that's known as reference counting to manage memory. And what this means is that most of the time it just looks at references to things. So if you create an instance of a class and then you assign another variable to point to it after there is already one, you increase the reference count, and then if the first variable goes out of scope, the compiler knows there's still one reference to that object in scope, and then when that goes out of scope, then it knows there are no references because the reference count has reduced back to 0, and it knows it can free the object. So yeah, as I said, iOS stores a reference count for each object, and behind the scenes, it increments and decrements these reference counts and knows when things can be freed. And it sort of means we get the best of both worlds. In the past in Objective-C, we would have had to explicitly write, retain, and release statements, and now the compiler just does it for us. And therefore, it alleviates a lot of these problems. Why I still mention this is that there are still places in iOS where we need to know this because it can still bite us. So as we encounter some of those in the unit, we'll talk about them. So as I said, we have reference counting, and this is basically the compiler doing this process for us. There's no runtime overhead, so this is really fast. But we need to just be aware that it's adding extra code for us and it's affecting our source files. So it's something to bear in mind. Okay, thanks for watching, and I look forward to meeting you in the workshop, and also in you getting to work on the lab exercises this week and put some of this into practice.